Alright, so this is the real setup of the diagram that Harry just explained. We have here the laser. It's a very strong laser. Here we have our first focusing lens. And then inside this box, we have our beam splitter. You can see it's this circle of glass, and that when the laser is passing through it in this direction, it's splitting it downwards. It's throwing a little dot onto the bottom of this box. So we don't want that split, and we're going to be concerned on the back, the return trip when it splits it up into this, which is our measuring microscope, which has two axes you can see through the lens, which allows you to measure the distance which this laser dot will move once we make the mirror start rotating at very high speeds. Here is our second lens, another focusing lens. Here's our rotating mirror. I'll turn it on so you can hear how it sounds. Oh, I'm not going to turn it on. Not yet. I'm not going to turn it on yet because we've calibrated it. We've set it up so you can see the mirror that it hits. See it hit the mirror the way that it should. Maybe that's part of it.
You can't see the dot.
Here's
there you go.
Here's the laser. It's hitting this mirror, which is about 13.5 meters away from the other mirror. I'm just gonna throw it back.
Back to this.
All the way back to our original rotating mirror here, which I'll turn on now just to you can hear how it sounds, see what it's like. So that's up to about 800 RPMs, and revolutions per second. The laser's gonna come back from that mirror in the other room that's 13.5 meters away, come back, hit this mirror, which is going to throw it through this lens again and back to the beam splitter, except this time it's going to be split upwards because it's hitting the top of this circle of glass at angled at about 45 degrees. And that dot's gonna be thrown up through this. We're gonna be able to look at it through this measuring microscope and see how far the dot moves once we start the rotating mirror.